Okay, for this one we are question 9. You've got a 1.8 meters is the speed that the canoes can flow at. Obviously the current is going that way at 1.1, so we want the vertical component of this 1.8 to be equal to 1.1. Therefore any of the horizontal component, I suppose, is acting. So we know that we want to find this angle here, so we actually need to get a base. Draw something like this. I haven't got a ruler, but you draw something like that. Okay. You then draw this to scale, to side of a scale. Now get a ruler, make a stair, say 1.1. It wouldn't be 11 centimeters. Let's say 5. Let's say it was 1 to 5. Okay, so 1.1 times by 5 centimeters. Let's draw that in there, and then just get your ruler and then just basically make a line that goes along here. So that's 1.8 times by 5, and see where it comes. Make sure these are at right angles, and then what you got to do is you got to physically measure off this angle here, and it comes to 52. Okay. Now the mark scheme allowed you to get 52 plus or minus 1. You had to have a suitable scale, so it took up more than half the paper, and it had to be shown this sketch in this way with a right angle triangle. So that's question 2. Question 9. Vector quantity. Okay, so when it says a vector quantity, you're going to say it is a quantity that has magnitude and direction. A lot of people said something, a thing, a this, a random thing. It's a quantity that has magnitude and direction. Give one example of a vector quantity. Well, velocity, force, momentum, acceleration, all of those things would be grand. I could go on and on, but not going to. All right, so that's question 11. Question 12. We've got to split these various components up into their bits, and we've got to try and find the weight, okay, the weight of the power center. Now the bottom line is, this is in dynamic equilibrium, it's moving, but it's not accelerating up or down. So fundamentally the upward forces acting on the paraglider, whoever he is, are the same as the downward forces. So we can basically first of all split this into its two components, 2.6 cos 41, 2.6 sin 41. And we can split this tension into its components, 2.2 cos 27 and 2.2 sin 27. Okay. Now the bottom line is the weight acting down and this component here are equal to this component here. So we're looking at these bits here to calculate the weight. So if we say the statement up is equal to down, well, the down forces are 2.2 sin 27 plus his weight, and the upward forces are 2.6 sin 41. Okay, so you shove that into there and you solve for that, and his weight comes out at 0.707 kilonewtons. And remember, there's a K, and these are all kilonewtons. These forces, says it there, little K's and all that lot. So that gives him a weight of 710 newtons, or roughly 71 kgs. Okay.